Everybody, it's Tyler here at the Chicago Robotics Invitational, checking in team number 3216, Robophins, coming out of Chicago here. And to talk about this robot, by the way, I'm here with Anthony, Toby, and Jason. And we're going to be talking about an interesting machine here, built in the basement, I've been told, as it went through. So we're going to be talking about, of course, the intake into the shooter, of course, in the wobble goal mechanism, a little bit of odometry and a roadrunner that goes into it. All some more coming up here on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. Hey FTC fans, are you ready for Freight Frenzy? Join us after kickoff live all weekend, September 18th and 19th, as we'll be out at Kettering University for the Bulldogs Robot in 30 Hours at youtube.com/first updates now. You'll get detailed breakdowns of game elements, the field, and prototyping and testing of robot components and assemblies. Watch live, view short videos after, and ask questions for the Kettering team at youtube.com/first updates now.
So we're going to start with the intake on this robot. So talking about some of the design process that went into it, and maybe some of the iterations as you kind of went through the season as well.
Yeah, for sure. So actually, when we started the season, we had this basic principle of this bar of compliant wheels, but at first, it was just on an axle that was fixed in place right here. And then what we realized is it would sort of kick the rings up a lot. So we adapted it to this free hanging mechanism. It starts the game, it starts the game up here, and then as soon as the robot moves, it falls down. So, and then this allows for a lot of play in the system for this to be intaked efficiently. Do you want to run the intake?
Yeah, let's see it actually come in.
Yeah. That's...
We'll call it audible on that one.
You're running it backwards. Yeah, there we go. And then it feeds into these polyurethane tubes, which take it up this intake. One thing that's been iterated with this intake is we've added this like metallic tape, which makes it much smoother going up, and also here, just to reduce friction. And then when it ends up here, it's in this 3D printed cylinder where we can stack up to 3 rings for shooting. And the shooting is done by these 2 counter-rotating flywheels. So how it works when it's shot is, you can see that, you want to flick the servo? This little servo will be flicked to shoot it into the flywheels. And then we have this thing, which will make sure that the next ring is flush against this piece for the next shot.
So you guys got a couple pretty large wheels for this. So some teams we see with just the one wheel coming in and having the compression on side. How'd you come up with like, hey, we want to do the 2 wheels and that's going to get us the right compression?
So what happened was we tested with single versus dual flywheel. And the thing is, when we started prototyping, the 1-to-1 motors were all out of stock already.
Sure.
So we realized that with a single flywheel, we couldn't really get enough power, was the main issue. And so we just ended up going with a dual flywheel. To our surprise, it was actually very accurate, more than we expected. So that was definitely a good surprise.
And then what's actually powering these as well?
These are 2 3.7-to-1 AndyMark motors.
And they're separately, they're not daisy chained or anything like that, right?
Nope, they're separately controlled. We have PID to regulate the speed. Yeah, so we're able to just set the RPMs instead of just relying on relative speed, which varies by voltage a lot. So that was definitely a big issue we found, which is as the voltage dropped with the battery, the speed of the motors would change drastically. Yeah. So, yeah.
Makes sense of that. So run us through, you got a pretty massive wobble goal grabber here. So talk to me a little about what went into that, some of the material use as well.
Yeah. Okay, so we have this. We have this claw, which is 3D printed out of PLA. So, like at first, we had a very small claw, which is made out of this like metal wire material, and we found it was just very hard to position in Autumn. So we've 3D printed these large claws There's 2 that are fixed and 1 that moves. And then we've also added this foam tape, which just adds friction. So it has a very secure grab. And like this allows us to be pretty imprecise when we come up to it in Auton. So like it can be all the way over here, and then do you want to close it? It'll just suck it in. And then it's stowed up here until we get to where we want to bring it. And then this can also deliver it over the wall very easily.
So looking at the competitors here at the Chicago Robotics Invitational, a lot of great teams are here. What is the one team that you've seen here that has really impressed you?
There's a lot.
There are.
I've been really impressed with Got Robot.
Sure.
We've like known them in Illinois for a while. They've always been an extremely strong team. I was very impressed by their like big drum for cycling their rings. I thought that was very cool.
And we've interviewed that team as well, so make sure you check out that interview too if you haven't. Well, 3216, looking really good here. Can't wait to see how you perform at the Chicago Robotics Invitational. Representing Chicago here as well too, so you got to make it happen. Good luck here at this competition and of course in future ones as well. Thanks a lot.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.